Hello Math 30-2. So today we're going to start off by doing a concept attainment of a sinusoidal function. So right here it says Mr. Forty has a secret about the value of c in this sinusoidal function. Notice c is the one inside the brackets. Can you figure out what it is? So when I change the number inside the brackets that we're adding or subtracting. So here's my first graph. It's just my basic general. We're looking at sine x. What is happening? So I had plus pi. So what's the difference when I added pi between these two graphs? What happened when I changed c? How did it affect the graph? Let's take a look at the second one. So now I added pi over 2. How did that shift? Look at where pi over 2 is here. Look where pi is here. Look where pi is. Okay, for that one. Those are my hints. Let's take a look at this one here. Okay. Now let's take a look at our last one. So this one was subtracting. Notice subtracting what happened. I subtracted pi over 2. Adding pi over 2, we went one way. Subtracting pi over 2, we went another way. Always look back to your original graph to see how it changed. Let's take a look at this one. Okay. And there we go. So that's subtracting pi over 4. How did that go? And where would be pi over 4 next? So now I want you just to think about that. Pause. Write down what you think my secret is about c, okay? So see if you can figure out what my secret about that c value is. Okay, so pause, and when you're ready, come on back. Okay, hello, and welcome back. Now we're going to figure out what the d value is. So that's the one outside of the brackets. So what does that do? So let's take a look. Here's my first, is my original graph, just sine x. Now we're going to change the d. So this is when d is equal to 0. Here we add 2. We add 2. That's interesting. Negative 1. We subtract 1. What happens? Maybe you could guess what's going to happen the next one. If I subtract 5, what's going to happen? So I want to see now if you can come up with yourself on what does that d value do to this graph. Okay? What's happening? What does it do? How does d affect the graph of sine? All right. So, before we continue, now we're going to look at this part here. And I have some graphs. So, hopefully you pause and you come back to this right now after you solve those. Now this is what's going to happen. So if we looked at it before, we have to know about horizontal shifts. So what is a horizontal shift? So this red is sine x, the black is cosine x. If I move this red, look what happens to the sine value. That is my c. It's being changed, isn't it? As I move it closer, all the way till right there, I'm on top. 1.57 is the same as pi divided by 2. So we move it pi over 2. That's negative. Or positive, we move it left. So if it's positive, I'm taking my graph, I'm grabbing it, I'm shoving it that way. And I keep on going, hey, I'm pi away. Oh, look at this. I am 3 over 2 pi. Okay? Now let's take a look. If I move it the other direction now. Here we go. So let's see if I move it. If I grab it and move it right, I start adding something to it. Look at that. Oh, if I add pi over 2, look where it looks like. Okay, that's interesting. So that's also why we don't need to do the cosine. We don't have to ever graph cosine. We use the formula. We tend to use sine. That's why it's called sinusoidal functions. We just shift sine over, add pi over 2, and it's the same as the cosine graph. Okay? Now, that should help you understand what the c value does. When we move things left and right like that, that's called a phase shift. Okay? It's a phase shift, or a horizontal transformation, or a phase shift. Okay? A horizontal shift is a phase shift. Now, what happens if we move it vertical? That is our d value. Now when we move our d value up and down, we move it plus, if I move it up, we add d. When we move it down, I subtract d. Okay? Now that is called our midline. We're moving our midline. Our midline is our line of equilibrium. So if I go up here, if I move it up here, my midline's moved. My line of equilibrium is somewhere around there, right? Now that line of equilibrium would be like if it stopped waving up and down, think if you had a slinky. The line of equilibrium is when you hold it out straight like this. Now as soon as I move it, I'm getting an amplitude from the line of equilibrium. When it stops, eventually it'll stop, and then we're back at our equilibrium. So that's the line of equilibrium. If there was no waves, okay, if the slinky wasn't activated, that's my line of equilibrium. Okay? So that's how that works. So now we're going to look at this part here. So it says, horizontal shift is called a phase shift. Keyword. Okay? That is our C value determines that. Next is vertical shift. That is a shift of the midline or median line, or also the line of equilibrium. Okay, so it's one of those three. So here's our first question. It says, draw the midline in each diagram. So I want to draw the midline in the first one. It is up here, right? There is my midline. My next one, the midline is somewhere down there, because it's in between these two, the max and min. That's my midline. So if it stopped, it would be around there. Would determine the equation of each midline. Well, the first one, it's my d value. My d value here is 1, so y is equal to 1. It's a horizontal line. At 1, y is always equal to 1. The next one is going to be y is equal to negative 0.5. Because here, d is equal to negative 0.5. Here, d is equal to 1. Okay? And that's how we get those. So take a look at question number 2. Question number 2. So basically, we're looking at sinusoidal graphs again, sinusoidal functions, these are graphs of sine. My first one, my thin line there is just the graph of sine x. Now, let's take a look at what's happening. We have 4 things that could be happening to it. Which one of these, one or more, is happening to A? So here's my black one. So first of all, the big bold one. So is a change in amplitude. Is there a change in amplitude? Well, I look at this, the max to min, and this max to min, there's a great big difference. So yes, there is a change of amplitude in that one. Let's take a look at the next one. Period. On my period, I start here and end here. Right? It's 2 pi. So 2 pi, 2 pi. So my period is the same. There's no change in period. Horizontal phase shift. Is there a horizontal phase shift? Did I move left and right? Okay. So did my C value be activated there? I look at this. No. I'm starting at my zero, or what my midline is, the middle of the graph, and I'm ending. Okay? So there is no shift left and right. My max is still lined up with my max. My other max is lined up with my other max. There's no shift left and right. What about vertical shift? Well, my midline is down here now. So there was a vertical shift. Let's take a look at the next one, B. So here's my regular sine x, and then we have my bold. First of all, change in amplitude. Well, here's my max, here's my min. This one's max and min is the same height, so there's no change in amplitude. Change in period. Well, this one here, I have 1, 2, 3. Oh, I have 1 max, 2 max, 3 max, 4 max. Here I have 1 max. 1 period and 2 pi. This one has 1, 2, 3, 4. 4 periods. That's interesting. 4 periods. So that must mean I have 4 periods, and this one only has 1. So we have a change in period. Next one, horizontal phase shift. Is it shifted left or right? Well, this one here starts at my median, like where it crosses the midline. This one starts at a max. My maximums don't line up, and it starts at a max. So there is a horizontal phase shift. Next one is vertical phase shift. Well, the midline for both of these is right here. So therefore, there is no vertical phase shift, okay, or shift in the midline. So next parts there just help you solve for C and D. And I'm going to continue on right here. It says, for each of these, state the midline. Well, we know from before in our little exploratory, the midline is always the D value. So in the first one here, the equation of the midline is y is equal to 10, because my D value is 10. Next one here, y is equal to, well, D is negative 4, so y is equal to negative 4. We shifted it down 4. Next one here is y is equal to D. It's kind of like, remember that formula? Y is equal to mx plus b, and b is your y-intercept. In this case, it's your shift. Same idea. Okay? In a way. Now, let's take a look at this one here. It says to use your calculator to solve, but I'm not going to use the calculator. I'm going to explain it out to you because I think that would help more. So, my midline value. Well, we know that's always equal to my D line. So, in this case, it's 5. This one here is 5. This one here is 5. 5 again. So it's always y equals 5, right? Midline value is y equals 5. Y equals, y equals, y equals. Now, next one says my maximum value. Well, if you remember, my maximum value has to do with my amplitude. It is my maximum, and my amplitude tells us, this one that's 1, there's an imaginary 1 there, how far away from the midline it goes, the maximum height it goes away from, above the midline, and the minimum it goes, the farthest below the midline it goes. So in this case, it is 1. So my maximum value is going to be 5 plus 1, is 1 above it, which is 6. My minimum value is 5 minus 1, which is 4. This one here, my amplitude is 4. So 5 plus 4, because it goes 4 above the midline. That's what that amplitude says. So we have 9. And 4 below, which is 1. Next one, it also has a 3 added there. Well, that 3 deals with period. Period has nothing to do with my max and min or my vertical. That's horizontal stuff, so we could ignore that. So we just take a look at this 2. 5 plus 2, because it says 2 above it, so we have 7, and 3 below. And this next one, we also added pi. Well, pi also has nothing to do with my midline, right? We already know that. That's shifting left and right. And midline's up and down. So we go 7 and 3, everything else is the same. Okay? So what do we notice about the midline values? Well, we notice that they stay the same always. It is always the VD value. Okay? Now the next part says, which variables or which values relate to the midline besides D? Help. Well, if I do know a max, I could use A to find the midline. Okay, if I know a max or a min, I could use A to help me find the midline. Otherwise, B and C have nothing to do with the midline. A can in certain situations, but most of the time it doesn't help much, but it can in certain situations help us find the midline. Okay? Because if we know A and we know a max, then we can find the minimum, then with the minimum we can find the midline. Right? Simple like that. Okay? So how can the midline be determined using only the max and minimum values of the function? Well, if I look at this, what's the relation between these two values and that? Well, 6, the midline is the middle value of the max and min. So the middle. How do I find the middle? It's like an average. So I'm going to add these together and divide by 2. 6 plus 4 is 10. Divide by 2 is 5. So I go max plus min divided by 2. And that will give me my D value or my midline. Okay? My midline, D, is always equal to that. Alright? So, eventually here, the last page there at the bottom, I suggest reading that. It tells you, or highlighting it, tells you what you need to know, and it re-explains what C does and what D does. Here are your formulas that you should be using constantly, so I would highlight this part as well. So let's try class example number 5. It says, determine the amplitude period of the equation. So we want to look at amplitude period and the equation of the midline for each. So the first one, amplitude is equal to 6. My amplitude is equal to 6, okay? Because it's always the A value. Now, my period is equal to 2 pi divided by B. And my B value for this one is 1. So it's just 2 pi. And we want my equation of the midline. This one is outside the brackets, so that's my D value. And my equation of the midline is the D value, so y is equal to 1. Next one here. Well, let's take a look at my A. There's an imaginary 1 in front of the sign, so it's just equal to 1. Okay? Now, let's take a look at my period. Period is equal to 2 pi divided by, in this case, it is 4, because my B value is 4, which is equal to pi over 2. Okay? And my equation of midline, well, there's nothing being added outside the brackets. So it's really plus 0 outside there. And this 8 is inside the bracket, so that's really a phase shift. So it's 0. Next one here says, number 3. Well, A value is equal to 0.5. My B value is 0.5, so my period is equal to 2 pi divided by 0.5, which is equal to 4 pi. And then my last part here, so we're done that, is going to be my vertical shift of the midline. Well, that is y is equal to 0.5. We are shifted 0.5, because that's outside the brackets, so that's how much it's shifted. That's my D value. Okay? So let's take a look at example 6. It says consider the sinusoidal function in this format. So we want to put it in this format. It's giving everything except for the phase shift, because phase shift can make things more complicated. Oh, sorry, forgot B. Which one is the phase shift? 2. So that's the only one we're subtracting in the brackets. So right here, we're going to go back to example 6. It says amplitude of 3. So we're putting it into 4. So A is equal to 3. We know period is 4 pi r, so B is equal to 2 pi divided by my period. All we do is we rearrange this equation like we learned last class. 2 pi divided by 4 pi, which is equal to 1 over 2, or 0.5. And the equation of the midline is 7. So D is equal to 7. So we put this into my equation. Y is equal to 3 sine x over 2, bracket, bracket, and then we go plus 7. Okay, let's take a look at the next one. We have an amplitude of 5 units. So A is equal to 5. Period is 0.5. So if I really want to go the other way, I go 0.5 is equal to 2 pi divided by B, and I just solve for B, which will give me 4 pi. Get B is equal to 4 pi. And then I want to know my midline is Y is equal to -2. All I do is multiply both sides by B, then divide by 0.5. Okay? So we get Y is equal to, we have 5 sine 4 pi x, and we are subtracting 2. That's it. Okay? Almost done here. So let's take a look at this next one. Question number 7. We're given our equation. Now it says, given the equation, determine to nearest hundredth the amplitude, period, and the equation of the midline. So we're working in reverse. So my amplitude, A is equal to 5.77. Okay? My period. And 2 pi divided, my period is equal to 2 pi divided by B. Well, my B is 20.28. I punch into my calculator. That's going to give me, to nearest hundredth, 0.31. All right? Now, we also want to know the equation of the midline is, well, this is inside, so that's my C. This is my D. Outside the brackets is equal to -7.5. All right, B. How can you use only the values in A to determine the max and minimum values? Well, how can we use that? Well, basically, all I have to do is my max is equal to my amplitude, how far away we are from my Y value. So it's my Y value, my midline, which is D, and then we have to add our amplitude, okay? Because the amplitude tells you how far away you are from the midline. The maximum you could go above, and the minimum you could go below. So my min is going to be D subtract A. So if I put this in my calculator, my max is equal to -7.5 plus, and we have here 5.77. Okay? And my min is equal to -7.5 subtract 5.77, which will give me a total of -1.73, I believe, and 13.27 negative. Okay? Now, here we go. Now it says use the equation. So here's my equation for this graph, but we don't know A, B, and D. So we're probably going to have to try and solve for that. So it says determine the amplitude and the midline. Well, my amplitude is equal to max minus min divided by 2, which is 1 minus -5 divided by 2. Okay, 1 subtract -5 is the same as 6. Divided by 2 is equal to 3. And my D value, which is my equation of the line, is going to be max plus min divided by 2, which is 1 plus -5 divided by 2. That's equal to -4 divided by 2, -2. Determine the period of the function. Well, I take a look at this. My midline is -2. There's more than one way of looking at it. I look at this part right here. Where do I hit that again? The value's right there. That's from 0 to 4 pi. So I could say, hey, period's 4 pi. Or I could go from my midline. We're over there. And then the next time it hits the midline, going up, right? Going up to hit the midline, and then going up to hit the midline is there. They're both 1 over 4 pi, 1 over 4 pi. So it's still 4 pi. So my period is equal to 4 pi. Determine the values of A, B, and D. Well, A, that's easy, is equal to 3. B is equal to 2 pi divided by period, or 2 pi divided by 4 pi, which is my period, which is equal to 1 over 2. And D is equal to negative 2. Okay, write the equation. Okay, Y is equal to, we have 3 sine, and we have x, or 0.5x, bracket, plus pi over 6. And what is this all together? We have to plus d, which is minus 2. Okay? Now, determine to the nearest tenth the value of that. So in order to do this, I have to plug this into my calculator. So I'm plugging it into my calculator, and it's already done there. And so this is how it's plugged in. You see there? Look where I put my values. 3 sine x, 3 sine 0.5 or 0.5x plus, and I put the pi over 6 in brackets, and so I have 2 brackets closing, and I subtracted 2. Now I'm going to graph it. And there's my graph. And it says we want to know the value of 11 pi over 6. So I'm going to hit trace, and go 11, and I'm going to have pi divided by 6, hit enter, I get negative 2.8. Okay, and that's it. I hope you understood this, and I see you tomorrow as we tackle the questions together.